Hello everybody! Today we're going to learn another method to solve quadratics, this time by completing the square. So this is another strategy we can use when factoring doesn't work. If it's non-factorable, we can use completing the square, but it's also not its own perfect method as well. So let's go over what we do. So completing the square is basically the same as what we've already learned, just with a little twist at the end. So we still have to look for the term to add to complete the square and make it a perfect square trinomial. We still factor it, but at the very end, instead of moving that c term back over with the perfect square, we take the square root of both sides instead. And then after we take the square root, that happens to make two different cases. So we have two different equations that we need to solve, and we'll find our x answers. So let me explain what I mean by this step 3 here, where we get two cases. So this example is x squared equals 9. So in order to get x by itself, we have to undo the square. The opposite of squaring something is taking the square root. So x is the square root of 9, and we know that the square root of 9 is 3. Great. Except that is not showing the whole answer. 3 is an answer, but there's also another option. What if I had negative 3? Wouldn't negative 3 work in this equation here? Again, the original equation, x squared equals 9. Negative 3 times negative 3 is 9, and 3 times 3 is 9. So both of these answers should be possible. And that's just all due to the fact that when you square a negative number, it becomes positive. So whenever you take the square root, what you need to do is you actually create two cases. So here's the positive case, where we just leave it alone. And then the other case, we put a negative sign in front of it. So in front of whatever was taken the square root of, that. So that's where we get our second part of the answer, 3 and negative 3. As we know, quadratics can have two answers, so this is how we achieve both of those. Okay, so now it's time to walk through some problems. The first one, x squared minus 12x plus 27 is 0. So I'm going to complete the square, and the first step is moving over that constant, the c value. Subtract 27 from each side. Okay, and now I need to search for the term to add here to make a perfect square trinomial. That's where you do b over 2 squared. So b in this case is negative 12. Half of negative 12 is negative 6. Square that, and that gives you 36. So the missing part is 36. Now this will be a perfect square trinomial, and I just need to add 36 to the other side. And now I'm going to factor this into its perfect square form, its factors. It's going to be x minus 6 squared. You just take half of b here in this case for that number. And then this is going to be positive 9. So this is the part of completing the square where you stop and go a slightly different direction. So instead of moving this back over here and setting it equal to y to look at vertex form, we're actually going to take the square root of each side. Because I want to get x by itself, I'm going to undo this square. And when I take the square root, that opens up the possibility to two different situations happening. We're going to need both the positive version and the negative version, so watch me write this. X minus 6 equals the square root of 9. That's the positive case. And we also have another one, x minus 6 equals negative square root of 9. So we have just two equations to solve. Square root of 9 is 3. We add 6 to each side, and this one says x is 9. This one, the square root of 9 is 3, and that's a negative, so negative 3. We add 6 to each side, and we also get x is positive 3. So these are my answers. I'll write it in a solution set, 3, 9. All right, so that's how you get your two answers. Another problem. This one might not be as nice as the other one. So let's start by moving c over, subtract 11 from each side. Now we do our little side work over here where we take b over 2 squared. So in that case, that's 8 over 2 squared, which is 16. So what I'm doing to complete the square here is adding 16 to each side. Now this is ready to be factored into its perfect square. Quantity of x plus 4 squared equals 5. So that's the completing the square aspect of it. Once we do that, we take the square root. Taking the square root creates those two scenarios, the positive and the minus. So now that the squared and the square root have been canceled out, x plus 4 equals the square root of 5, and x plus 4 equals the square root of negative 5, or negative times the square root of 5. So since we don't know what the square root of 5 is, it's not an exact number. So we're going to leave it like it is. And I'm going to subtract 4 from each side. And that's going to be equal to negative 4 plus the square root of 5. And then for this one, we're going to subtract 4 as well. X is equal to negative 4 minus the square root of 5. So this is the answer that mathematicians would prefer. They want it with the radical, which is the most accurate. But if I'm interested in the actual number, it's going to be decimals, but I'd like to know. So we have negative 1.764 about, and negative 6.236. So either way is acceptable. Oftentimes delta math prefers your answers in terms of radicals. So you'll need to keep the radical. And that's just the way life is. And it's not always perfect. Okay, and now one of our harder ones. This is where the a term is not equal to 1, so we have a little bit more difficult time. And it's not all on the same side of the equation. So we need to move 7x over as our first step. Two x squared minus 7x equals negative 5. So now we've moved c over, and we need to factor out our a. Unfortunately here, 7 is not an even number, so it doesn't evenly divide out. So we're going to have to write it as a fraction. Half of 7 is 7 halves. And now I'm ready to think about completing my square. So this is, again, b over 2 squared. That's 7 halves over 2 squared. Now, dealing with fractions, 7 halves divided by 2 is like 7 fourths. So we just multiply these two numbers here to get the new denominator. 7 fourths squared I'm going to apply the squared to each of those. So 7 squared over 4 squared, which is 49 over 16. 49 sixteenths. Again, it's looking like we're not going to have a nice, simple answer here. But I'm going to add 49 sixteenths to my quadratic. But what I'm really adding is 2 times that. So 2 times 49 sixteenths is what I add to this side. And really quickly, I'm going to simplify my fraction. 49 sixteenths times 2 is going to simplify down to 49 eighths. So I will add 49 eighths. I'm going to write my perfect square. So again, it's half of the b term. Half of 7 halves is 7 fourths. Now I'm going to add these fractions up. So I'm going to rewrite negative 5 as negative 40 over 8. Negative 40 over 8 plus 49 eighths is going to be 9 eighths. And now here is where you usually move this over and you have vertex form. But in this case, we're going to do something different. We could take the square root, but we need to get rid of this coefficient first. So you need to get rid of the a coefficient before taking the square root. Divide by 2. So 9 eighths divided by another 2, that's going to be 9 sixteenths. And now that the coefficient is out of the way, we can take the square root of each side. We've got two cases, positive case, and I'll write down the negative case. So we're going to add 7 fourths to each side. And we can actually simplify this a bit. Square root of 9 sixteenths can be written as the square root of 9 divided by the square root of 16. And the square root of 9 is 3, The square root of 16 is 4, so that's actually 3/4. So we have 3/4 plus 7/4, and that's 10/4. 2.5 in decimal form. Okay, so I guess it wasn't that bad. There's our first x. Now we have to deal with our negative case. So again, square root of 9/16 is equal to 3/4. So we have negative 3/4, because it's our negative case, plus 7/4. That makes 4/4, which is 1. So our solutions are x is 1 and x is 2.5. All right, so just follow those steps and you should have success.